Another beautiful day. So let's start. Not this screen. Where is it? Geeks for Geeks. Yes, this one. So today, after solving, where is the screen, man? It's getting lost. After solving this, no, this I have solved today. Another interesting question. Check if linked list is palindrome. On lead code, it's what we say, an easy type of question and quite easy to understand. So not such a big deal. Let's get rolling. So what does the question say? My setup is little bit incomplete. My notes, I am creating the what we say space for the notes. So how does this go? We are given a single linked list of size n. The task is to check if the given linked list is palindrome or not. So this is our linked list, 1 pointing to 2, 2 pointing to 1. We have to just pass true or false. Um, should I give you the answer upfront? So one of the approach is brute force, where we will be using stack. You might wonder how. For that, we must go on to our notes, means our handy, what do we say, dry run on paper. This is our 32nd, no, 31st question. Aryan for today is 14th of March. Time flies very fast, man. Palin, you might not able to see or what. Palindrome linked list. How does this go? So what are the example given by Geeks for Geeks? 1 to 1 to 1 is quite simple. It's okay. Smaller the example, better we can understand. And smaller the dry run. Uh, so brute force. As we know what a palindrome is, whose ending characters are equal. But if it were arrays, it might be very easy. Since it is linked list, approaching this question might be tricky for beginners. So this is our linked list. As I told you, create was stack. After creating a stack, we will iterate the whole linked list and store all the values into the stack 1, 2, and 1. And while popping, we will come. Uh, so the time complexity out here might be high compared to the brute force optimal approach. Why? Because first we are iterating the whole linked list and storing in stack. then popping the elements from the stack and comparing every element. So store in stack, sorry, it's not stack, it's, yes, it's stack. And then pop and compare is the second operation. Space complexity would be O of n because we are storing using stack to store all the elements. What else? Since it is not recursive, no stack, call stack. Let's just jump directly into brute force or optimal. What the optimal says is, for this we will require a larger array linked list. Here first using find middle, using which approach? Fast and slow approach. Then what we will do, from middle to end, reverse. After reversing, we will compare first and middle most element. Mm, For this, if the length of the linked list is odd, no problem. We will see in implementation. Why? Because means let's do a dry run, man. Why I'm not doing a dry run? Let's use blue pen. 1, 2, buckle my shoe. 3, 4, set the door, slow and fast. 1, 2, 2, 1, 2, 2, 1. Slow will move one step, fast will move one step. Then slow will move again here, fast will move. Let's use black pen for fast. So slow came one over here, then here. 1, 2, 3 hops. 1, 2, third hop over here, fourth hop outside. 1, 2, 3, 4. So this is the middle. Mm, After which we will reverse it. 1, 2, 2, 1, 1, 2, 2. Our head would be 1. So head 1, head 2. We will compare. Should I remove this to null? Mm, Let us think. If I move it to null, there is no problem as such. Yes, we can do it, point it out to null. So What is the time complexity, you might ask? Since we are traversing the whole array once and other time half, the algorithm traverse during the first half, it reverses one half of list. During the second, it compares the elements of both files. Each traversal n by 2 elements. The time complexity is calculated as n by 2 plus n by 2. I'll compare the every element. So past and slow pointer iteration, we can say it as n by 2. Then reversing this part can become another n by 2. 1, 2, 3. Hmm. Okay, so I was just thinking, finding middle, it's taking n by 2. Then what? Reversing, it's taking n by 2. Then the whole n for comparing means n by 2 plus n by 2. Middle, find middle. What is another n by 2? Reverse. Half. Comparing. Oh, so space complexity is O of 1 because we are not using any another data structure for calculation or storing answers or call stack for recursion or something. So let's just go into the coding part. Hmm. So let's think. What are we going to do? Should I do the brute force approach first? Yes. Why? Because for many, for a long time, I have not touched stacks, how it works, the functions, which functions are used. So let's do it. Stack integer stack is equals to new stack. So after this, we will have to iterate. For iterating, we will need another temporary variable from head. What will that temporary variable do? It will push all the elements dot push. Am I right? Temp dot data. Temp is equals to temp dot next. After pushing, we will reinitialize temp to head while temp not equal to null. If stack dot peep not equals to temp dot data. This means unfortunately it's not a palindrome, so we will return false. Else we will do stack dot pop, and what else? It's peep or peak. It's peak, man. Then what else? Temp dot temp is equals to temp dot next. So simple. If this whole linked list is iterative and we didn't find any violations, we should return true. Let's accept the privacy policy. Accept it. What's taking so long? Let's rock and roll. This is going to run 1,000 test cases. Oh my god. What else? They implemented a better UI. I feel. I like the previous one. It gave more details. This is very lack of information in this. I can't care more. Let's implement optimal approach. What we will need for that? Node fast is equals to head. Node slow equals to head. What else? While fast not equal to null and fast dot next not equal to null. Why I do this both condition? Because the linked list can be odd valued or even valued. Where I am right now. Should I write the reverse code first? Reverse the linked list code I have to write. I have to check is palindrome. Fast not equals to null. Why I did these changes is because fast will move this put fast dot next slow dot next it will come over here. Then this. So now if we did fast is not equal to null it will go again. But we got the middle but it's going again. So the middle part we are not able to find it. What I'm saying, see, slow and fast are over here. Slow will come over here on the next operation, and fast will come over here. So at this point, we have got the middle. But if we do another iteration, because fast is not equal to null, and it is an AND operation, so both conditions should be true. So since one of the condition fast dot next is not equal to null is true, that is not a problem. Let's check an even thing. Slow will come here, fast will come here. Fast dot, so we are taking 2 as the center. That is the reason why fast dot this should be the middle. But if we had fast not equal to null and fast dot next not equal. So it will try to go ahead again, resulting in 3 being the part of the left part. But what if it was 1 2 2 1? So 1 2 2 being on the left and this being on the right, there is no even separation. For even separation, we could use this condition. So now slow equals to slow dot next. Fast e- equals to fast dot next dot next. What next? After reversing, sorry, now we have to reverse. So for reversing, let's write the code. Node reverse node head node previous equals to what? Null. Node current equals to head, while current not equals to null. Node next equals to what? Current dot next. Mm, current dot next equals to previous equals to current current equals to next. Just return previous because it is our new head. Let's store this. New head equals to reverse slow dot next. What else? We will take two variables, reference variables, one pointing to head, second pointing to new head, while second not equals to null. What we will do? We will check first if first dot data. Why we are not doing first equal to? Because they are not same variables. They are different objects with same data. Second dot data. What next? Return. Acha, let's do this. Not equal to return false. Was this the case? Return true. My water break gave me an error. Let's see what's happening now. I'm taking another water break. Let's go. Yes. I don't want anything to go wrong. It's not going to be wrong. You get marks only for fast correct submission if you solve the problem without doing the full solution. Hey man, I know this. Chalo, guys. My relatives have come. I have to leave early. Thank you for being part of this stream. Have a good day for rest of the day because half of the other day has been completed. Okay. Good night. Shabak hai.